Thank you. Good morning. I'm not sure I moved up when I left being a developer. Perhaps I moved down to be, coach, because I really like the work that's done by people to help other people. That's why I'm in computers, to get rid of low-value stuff that humans do. So my motto in life is this: don't let a human do a computer's job. So let's get away from that. But I'm going to talk about my past experiences. And I've been a product owner for what's been called a DevOps teams. Not just one, but several. And let's see if we can get this working. Yeah. And I love it. I really love it. Because when we do continuous delivery, when we focus on, the full chain from getting to A to Z, everything comes together. How you slice your organization, how you slice your backlog and your work, how you set up your teams, architecture, how you think of your runtime, how you think of how your business models with your users. When you really go for continuous deployment or delivery, all of this comes together, and that's why I really love it, because it's lots of pieces that needs to go together, and that's me. I'm from Sweden. I live on the best coast of Sweden, which is the west coast of Sweden, in a city called Gothenburg. I'm wearing this blue shirt. It's from Scrum.org, so I'm one of the 160 professional Scrum trainers around the globe. So I do some teaching, but primarily I'm a consultant, and I spend at least 80% of my time with one primary customer. So what I'm talking about today is my experiences from the past 3 years with different customers, really having my skin in the game. So let's look at two cases. I'm going to talk about the telco, the telephone company. Obviously, they have landline telephones. They also have cell phones. They sell cell phone contracts and cell phones, sometimes bundle, etc. All of this happens over the web. They have IPTV services, where people can order different set-top boxes and stuff like that. Of course, there's also internet connectivity, so routers, gateways, those kind of things is also involved. And the 15 teams that I worked with, they were in charge of all the customer communication channels. So we have smart chat bots that try to figure out what you were doing. We have live human chat systems, Twitter, Facebook, and of course all the web shops and my pages, where you can see how you use stuff and things, your data usage and stuff like that. So that is one of the cases. This company is one of the biggest international data carriers around the globe. So it's high security awareness. Hackers would love to be inside of these networks because they would have access to a lot of bandwidth and a lot of data to sell, probably. So if you look at the runtime, the operations of this company, it's different people from the ones that are developing. And of course, this limits what you can do in continuous delivery. So that's one case. The other one is the really, really, really big monolith. One system like this, for the end client, becomes the heart of that organization. It pumps the information on who should do what, how should we run our operations of the company. So every time we did a build, it was 700 megabytes of new data. We had roughly 18 teams working together on this product. And once again, in this situation, my client, they didn't have control of the operational situation. It was the end client, or the client's client, that actually maintained the software in production. So I'm going to tell you a little bit how we try to accommodate for that. But before I get too deep into this, I'd like you all to say hello to someone new, not the person next to you that you know, but someone else. And then you take 2 minutes and you see what's the difference between continuous delivery and continuous deployment. If you know. If you don't, ask the other one and see if they can explain. So 2 minutes starting now.
Time's up, people. Just a quick, there's going to be a Q&A session through the microphone, but for the shy people of you, there's panelsensor.com/AGS, where you can post your questions, like and dislike a question, and if there's traction, we're going to pick up questions. But there's going to be also questions from the audience at the end, 5 to 10 minutes. The floor is yours, Fredrik.
Okay. So I would like to know what all of you think, but that's going to take some time. So this is how I think of it. Continuous integration is when you obviously push your code into a central place where you can build it and you can test it. And you really answer the questions, will it run? Will it build? Moving to continuous delivery, you care for a bit more like what happens when we install it. Will we overwrite the data, or will the data survive? What happens to our logging systems? You know, the things that should survive from one version to the next version. So it's more about, are we ready to ship all the time? Yeah, that's what we aim for. We are ready to deliver at any point in time. Continuous deployment. By that I mean we don't only are able to ship, but we do ship. As soon as a commit goes through all the automatic testing in the pipelines, we ship it to live production. And this is where very strange things happen. You move from answering technical questions, whether things will work out, whether it has the right functions, to, are we having the right impact? This change that we introduced, the commits that went through the pipe, are they actually now having the impact on the system that we expected to? And this moves us to the business questions. So one of the first things I've learned is, when talking to clients, running continuous delivery workshops, really understanding why you want to do continuous delivery or deployment is important, because there's a huge cost to this typically. It does not come for free. So you need to know what are the benefits. So for the two cases I'm talking about, time to market was one of the leading things. We want to make sure that we always can ship. So we want in a good state, we want to have automation so there's no need to wait for things. One of the clients were really interested in the impact. We are throwing so much money in here, do we get an impact with our users? Do our product owners understand the market? Can they affect the market? So this one up here was about continuous delivery. This is continuous deployment. The next thing I learned is that you should not start from the beginning. Oh, sorry. It's actually missing here, so yeah. Do not start in the beginning of your pipelines. Don't think so much about your continuous integration, how to get your fast feedback back to developers, because developers are going to figure that out. That's my experience. Instead, you should focus on the end of the pipeline, where you go close to your deployment. Think about how your system is supposed to run, how you're supposed to upgrade it. What mechanisms do you need? What do you want? And does your system actually support it? Do you have the architecture to do rolling upgrades or having multiple versions or not? Start at the end, because when you start figuring these things out, it makes it much clearer how you need to form your pipeline system backwards all the way to developers. Start with the end. And when you do that, it's also very easy to start communicating in a big setup with many teams about what is our common goal, how do we want our system. You know, we ship as one, right? So there's only one system. Even if there's 150 to 200 developers caring for their code, we ship as one. The same thing with the telco. Even if their deployment units were separated and isolated, the clients still think of us as one. Whether I do IPTV or telephone, it should look the same, it should have the same feeling. The system should know about me as a client. So start at the end. Draw that picture of how you want this to work, and then visualize it. This is blurred out by legal issues, but this is the information radiators we set up all around the office. You could not go out from an elevator or from the stairs without seeing what is our state. So here's red, that's not good. Yellow is almost not good. So start sharing this information. It's made a huge difference for the teams to come together as one and not just care about my component. It looks good, my unit tests work. No, you need to care about it all the way this far out to the end of the pipelines. So make sure you provide this information to them. We also started tracking and visualizing the pipeline health. You know, how good is our pipelines? How often do we break? How fast do we recover when it breaks? How many of you have heard that you should not have a red pipeline for more than 10 minutes? Okay, so that's, I think we had like 13 minutes by the end when I left. It was not 13 minutes when we started. And of course, red pipeline means something is stopping us from going live. Our time to market is now being paused because there's something limiting us. So this is one example of such an information radiator. How well is our pipelines doing? I'm sure you can think of something else. On the topic of continuous integration, how often should you do that? Well, as often as possible. If your build or your pipeline from start to end takes 30 minutes, how often should you run this if you have change sets coming in faster, like every 3 minutes? Would you create 10 instances of the same pipeline and have them run in parallel? Or would you batch up your commits and run just every 30 minutes? What would you do? Hand up if you would batch them up and only run every 30 minutes. Okay, the other hand up if you would do it as often as possible. Okay, I'm not going to say one is better than the other, but you need to be aware that when things start to happen really quickly, typically the pipeline system isn't able to catch up. So either you have to add more hardware so you can run them in parallel, or you batch things up, which is interesting. So what we did for humans to be able to really go into the system and verify flows, we had 2 deployments per day called LASSI, the latest stable system increment. So we deployed it at 6 and 12. And you could also do it manually, of course, if there were known bugs and we wanted to retest again. So let me tell you a little bit more about the team that I actually worked with, the DevOps team. Has anyone of you seen this DevOps topologies site? It looks something like this. It has pictures of different setups for DevOps. You have a DevOps team in the middle trying to get away. Then we have one that overlaps, etc. Have you seen this, anyone? I strongly recommend you go into devopstopologies.com and just read up on this. It's insightful, very clear to understand, I think, and it's a good exercise for your organization. Think about what can we do? What would fit us? Our product, our setup, our business model, our culture, etc. So, previously with the team that I care most for, this was the configuration management team, the CM team. But we decided we cannot work in that same way we used to do. So our guiding motto was really to do configuration management with other teams, not for other teams. We pair up with people when they come and ask us things. They say, yeah, we'd love to help you. Come sit here and I'll show you how to do it. So after some time, people understood that, no, we actually are empowered to do this ourselves. We can take control over Jenkins builds, etc. And some people started doing that actively. And in order for us to scale, we started to set up this community of practice for build engineers. And typically this was something that one person in each team did on perhaps 10 to 50% of the time. Instead of centralizing this thing, we set up a community of practice where we shared knowledge and we started doing stuff. Like test this out. Let's see what happens if we use TeamCity and convert all the pipelines for Team X or Product X to TeamCity. that made a huge change in what we as a DevOps team could focus on. Instead of focusing on small stuff, we could focus on the future, how to provide better tools, how to analyze our data from all of our pipelines. So let me just dig in on this with community of practices. How many of you have community of practices set up, like an architecture chapter or some guild of some sort? Okay, a couple of you. Raise 2 hands if you think they are extremely successful. A few, okay. This is hard, in my experience. It's typically turns out to be a place for people to go to just complain. Talk about issues and problems. And then they go out and they come back next week and they complain the same thing. But now no one has fixed it, and they come back next time. Oh, no one has fixed it yet. So what I see in the community of practices that are really living well, they do things. Like we said, they try out different tools. We try to refactor code. You can't do that in 45 minutes. You need to have longer sessions. So mix the discussions with really long sessions, like we're going to do this for 2 hours or 3 hours. We're going to try this out. And if you look at program retrospectives, or Nexus, or whatever you want to call it, release train, those kind of things, make sure you empower those as well. If you have teams coming up and saying, we've been struggling 3 sprints with this input-output architecture, the code is a mess, it's complex, it's slow, it's hard to test. And if the people suggest that we take 3 people out of the 150 for 3 weeks, trust them to do this. What else did we do? We moved away from sprints. You know, I'm Scrum.org guy, and I moved away from Scrum. It's okay. This is what our room looked like. We had the dashboard, you see in the information radiator, and these were our priorities. We had short-term priorities to the right, and long-term to the right and short-term to the left. So whenever we did our dailies, we just started from the top. We used Jira to track work, but started at the top and said, do we have any blockers? No, good. Do we need to do any work for sustaining the current versions? No, good. Users conference, yeah, someone needs to work on this. So we just went down from the top bottom and made sure that we work on the most important things day to day. And this changed perhaps every week, every second week, the priorities. And that worked really well for us because our primary goal was not to deliver new functionality. We did that as well, like how to install the system. We had all of these orchestration. But primarily, we were spreading knowledge. So when we worked with sprints, we did a plan that never worked out. And people asked us, so why doesn't your plan work out? Well, we did this and this and this and this. And they said, yeah, you did the right things, yeah. So everyone agreed we did the right things. But it was mostly unplanned when people come and ask us questions. We couldn't see when people were coming to ask questions. We couldn't foresee that. So instead, we just did away with sprints, and this just worked really well for us. When I first met this DevOps team, they came to me, and I didn't know them. I was doing a TDD course, test-driven development. So I met a couple of people that really didn't program for a living. They were most like, system automation, system testing automation and stuff like that. And they wanted to have test-driven development course. And I said, well, yeah, sure. So we had a workshop every second week for 10 weeks. And we talked about the principles of test first. We tried it out. We didn't do bash, testing in bash, but we talked about how to do these things and how to do it with infrastructure. How can we apply this on infrastructure automation? So obviously, we need virtualization helps a lot. Having parallel systems, parallel networks, having parallel binary repository managers, all of these things, so you can try things out in a safe way, make sure it works in isolation, and then move into production. So test-driven development and infrastructure as code. We talked about this often. And it makes us realize that we need to come to this conclusion. Snowflakes are not okay. We have to move to Greece, where it's warmer. No. How many know what a snowflake is? What is a snowflake? Yeah, all of you said it's a unique server that no one knows how it was set up or can reproduce it. Pretty much. Or a system that no one knows how to replicate or reproduce. So this was also one of the mottos. We are not accepting snowflakes anymore. Which led us to this. We realized we have lots of snowflakes. We have lots of broken windows. And we need to fix this. So relentlessly, we read the Phoenix Project together to understand how to collaborate, how to get rid of the unicorn problems, because we had like 5 unicorns in this team, really high-performing people. But automate everything is the solution to get away from snowflakes. Everything. Like the reminder to go to Nexus Daily Scrum, etc. We had a little CD-ROM drive that jumped out and had a teaspoon that dingled like this. It says, ling, 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 ling. That's how we automate our lives, how we did it. Eventually, this led us to the point where we said, you know, what we do is not important as in terms of what we produce. What we learn is most important, and how fast we learn. So we got really good at pairing, you know, system, infrastructure, people pairing. That's not very common, but it had great benefits. Productivity went up a lot, simply because work never had to wait for someone who knew something. We started spreading knowledge, competencies, and skills. So we did swarmed, we did mob programming, especially when there were like priority 1 or 0 issues coming in. All hands, focus, stop. What caused this? How are we going to move it? Someone work on the quick fix, someone work on the long fix, immediately. And one of the best things I saw with this team was introduced and what's called the buddy bench. And this is something we brought in from kindergarten or daycare center. If you're a child and you don't have someone to play with, you go sit at the buddy bench and someone will come pick you up. So we did the same thing. Whenever you were done with the task or a job, you go into the middle and said, hey, I'm a lone buddy now. Can someone come pick me up? And then you started pairing with someone. We also made it a rule that no one is allowed to start on the task by him or herself. No one is allowed to start by themselves. Because in the beginning of the task is when you do the most complicated stuff. You break down, you gather information, you need as much information and knowledge as possible. So never start on a task alone. And once you've solved the difficult parts, then it's okay to split up and do the easy parts on your own. But never start work alone. So, this effective DevOps team were we agile? What were the agile principles applied to us? I mean, you have your planning, your daily scrum, review and retrospective. But that's not really where you are agile, right? In order to be agile, this is where you need to do these things. This is why we practice these things on how to get to a good level of automation, etc. And, you know, in this white area, the big part of the work, this is really where you make decisions as well, right? You cannot wait for decisions to happen over here when the PO is available or something. You need to understand what to do here all the time. So we moved to the place where I, as a product owner, never walked alone. That's not completely true, but whenever I walked into a meeting with someone, with our customers, which was the other 18 teams, I always brought along at least one, but ideally 2 people from the group, so we could understand the client better, and I didn't have to, you know, parrot everything, rephrase everything. the understanding was already in the group. So I can focus on the future, what we need to do next, and the teams understood the clients and focused on the day-to-day operations. I'm going to talk a little more about pipelines. You can't do continuous delivery without pipelines, right? So some people have to maintain multiple versions of their software. That typically means you need to replicate things, reproduce things that were done in the previous. So version controlling your pipelines is hard to do, especially if you have a mesh of something like 54 Jenkins servers, where every autonomous team is allowed to do whatever they want. That's one difficult grid to keep track of. It leads to various diamonds problems, etc. So while we wanted autonomous teams, we think of the teams something like this. Yeah, you're allowed to do almost whatever you want to do, as long as it's version control and you can reproduce it. But there's a contract here where you deliver your things into this binary repository management system. Once you have done this, we have the centralized integration taking over, where we produce it's actually over 100 systems at the end, because there's a core and then there are customizations for different clients. So we have almost full autonomy here, but there's a contract that you need to fulfill in order to get your stuff delivered. Version control, how you build stuff, and some properties around the binaries, of course. So we rather quickly moved away from Jenkins. It didn't allow us to scale in the way with the support and the traceability that we needed, and we moved to a tool called GoCD. Has anyone used it? It's a ThoughtWorks internal tool that they now have open sourced since 2 years back, or 1.5 years back. It visualizes your pipeline in a different way. It helps you think about pipelines in a better way. I strongly urge you to look into this tool as a way to build a big system of pipelines. So this thing about autonomy then, feature teams, isn't that the best thing in the world? Perhaps. I don't think it works everywhere all the time. I don't think that's pragmatic. I think a mix can be very good. If you start having feature teams like this, my experience is that we had to put together teams of 14 people in order to cover all the parts of a system, this monolith system. It was the same thing for the telco. The teams got really huge. So what happened is that when you only have one person in that team, and you think about data access perhaps, one team starts moving in this direction and another one moves in this direction. So what happened is it was a really hard time to keep things together, to have good code base in all layers. So if you're going to do this, make sure you have a culture where your community or practices does things, really do things together, so that you have control over their situation. So one of the organizations really didn't, so they went back to having a few component teams at the bottom, and then they had like desktop teams, web teams, machine-to-machine teams that built on top of the platform. And that worked fairly well for us. The thing is that it introduces dependencies. And some go really deep then, because you need to touch not just 1 or 2 teams, but 3 teams. And if you're in that, you're in deep problems. You're going to need to do deep planning ahead, and it kind of slows you down. It makes things difficult, more things to keep track of at a longer time in a period of time. So try to avoid it. And in this deep situation, I'm actually going to ask you to take another 2 minutes to summarize what you just heard. So talk to the person you just talked to before and summarize this talk or this presentation. Thank you. Please go ahead. Start now. Oops. All right. So thank you all for having this summary. I think you should applaud yourself for doing the summary. So good work. Thank you. So I'm going to stay around for the entire conference, and if you'd like to talk more about how to do cross-team refinement, definitions of readiness perhaps, or OpenStack, or how we did our iterations and stuff like that, I'm happy to answer any questions. And I think we have some time right now, right?
Again, a big applause for Fred. So,
Thank you.
we have some time for some questions here. There are no questions in the panel sensors. I told you guys, you shy guys can use it. So we can take questions from the audience. So please, hands up, the ones, now it's your time. The man is here, come on.
So yeah, can you repeat again how you actually structure teams, both in terms of features and in terms of components?
All right, yeah. So obviously this is different depending on your architecture and your platform and your system and your culture. But what we did with these 18 teams is that we had 3 teams at the bottom. They really provided a platform of data management, like ORM, but much more intelligent. And on top of this, we had more complete feature teams, what you want to call it. They did user interface design, user experience design, those kind of things. So those are centered around desktop applications, real rich client, web. We have machine to machine, that is, as they were pumping the information through the organization, we had lots of interfaces with other systems and lots of ways to export the information. Platform and then feature teams on top of it. Like an operations team, if you want to call it that. Operating system, yeah, okay, yeah. Pretty much like an operating system or an SDK. If you want to connect and get some data, here are the APIs, this is how you do it. But it was a very close collaboration. So typically we had in-sprint dependencies where we worked together to define the APIs and how to use it.
Come on, people, another question?
Thanks. We do have the same idea of applying what we call feature teams and core teams. I just wanted to know whether you feel that the personality of team members might make them more eligible to go on a core team or not. Thanks.
So the question of personality. My experience, no. I've seen the same type of personalities in feature teams as in core teams. I do have experience of people saying, I've been a programmer here for 15 years. I don't need to stand up once a day and say how I'm going to be done on Friday. I am done on Friday if I say I'm done on Friday. So some people are not happy with collaborating as a team in general. And then that doesn't matter if it's a platform or core team or whether it's a feature team. This is more like a how do I like to work thing. I think that is more relevant than other characteristics.
We have time for another question. Come on, with some hands.
Hello.
Hello.
You talked about 18 teams and one team of your team. Okay. How would this scale down to a single team of developments? And how many persons should carry out your tasks?
Wow. So with one team, how many people should care about infrastructure, automation, those kind of things? Yeah. As many as you need. How should I know? It really depends on how you build it. If you go for serverless and you don't have any infrastructure, everything is hosted in a public cloud, of course you will need less because your platform should support you and give you the tools you need. If you need to run everything internally and do all of that automation yourself because of some legal requirements or whatnot, you will have need to spend more time doing it. I don't have a good guideline, I'm sorry.
You can also discuss it over the break with Fredrik. He will be around.
Absolutely.
One last question, guys. You?
Yeah, so going back to the 54 Jenkins servers.
At least.
Yeah, what was it that prevented them from working together? Was it the orchestration between the different builds running on them? What was the failure there?
So we wanted teams to really feel that they own how they produce the binaries that go into the system, which means if they wanted to use, they didn't have to use Jenkins. They could use any tool they wanted as long as we can version control it and set it up. Eventually, teams moved to Go CD instead because that allowed them to track their work all the way through the entire setup, the full pipeline system, but preventing them to come together. Yeah, we wanted them to add the plugins they wanted, to have the setup they wanted, to have the dashboards, plugins, etc. And just having 18 teams go around and play with one Jenkins configuration, our experience with Jenkins is just, sorry, it's not a tool for that kind of setup. So we split it up and said, here's your server, do whatever you want, version control it, and show us how you do it. Here are some good practices that we know of. So we had a basic setup for teams that didn't care. Then here's your server, just press play, push your code, and it will run. So there was some centralization and reuse of patterns, of course, but yeah, tracking work between 54 servers is not easy.
Okay, thank you very much. Again, a big applause for Fredrik, please.
Thank you. Thanks for the good questions.